Okay, hey guys. Last Thursday in class we went over everything we'd need to get our simple MUD game working, such as the game characteristics like the map, player attributes, and experiencing and leveling system. But seeing as the CA where we defined all those things is already in, instead of running through them again in this video, I'm going to run through and explain the code of the sample game John showed us in class. Okay, so I have the project loaded up here in Visual C++, and I'm going to start running through the code from the program entry point, which is found in the demo 0801 file. The first thing the game does is it loads its item database and player database from a file. The item database and player database both inherit from entity database, which contains a static map, which means that both databases are using the same map to store their entities, and it also contains pretty much functions to make it easier to interact with the map and an iterator to go through them. So if we go into the load function, for the item database, we can see here that we're using a file stream to read in data from a text file, well, a .itm file in this case. So I'll actually just open that up here to show you what it looks like. You can see here that in the item class they've got an ID, a name, a weapon, all the different stats, and that's how they're organised in the actual file. So if I go back to the Visual Studio and the program, we can take a look at how that works. Right, so first of all we set our input file stream to the file that we need to read from, which is the items.itm in the items folder. We make a temporary variable with a string and an entity ID. So basically, while the file is good, while we haven't come to the end of it, we use the file input stream to read the first item in the text file into temp, which would be the bracket ID bracket, and then we read the next part into ID, which would be the ID number. We set the map ID to be the entity ID, and then we read the rest of the file into the map, which is an entity. The reason we can do this is because we are reading an entity into the map, and this part, sorry, not an entity, we're reading an item into the map, and this operator in the item class has been overridden so that it knows how to load the rest of the item in. I'll actually just show you that now, and sorry, this is just to get rid of any white space afterwards. I'll show you it in the item class. Actually, pretty sure it's in the header. Yeah, here we go. An input stream operator it's overriding it. So it's got the stream coming in. It reads in the p stream the temp, which is like the bracket part again. Gets rid of the white space and calls the get line from the stream to get the next part and store it in i.name, which is the item name. It then just repeats a similar process for the rest. This is getting temp and storing it in temp to get rid of, so that we can use it to find the item type. So it'll load in like knife would be passed into item type, and then we'd have get item type. And the process is pretty much just repeated. So it reads in like the bracket name part and stores the information in the item. So I'll just go back to the item database now to see if there's anything left, and it just logs that the item was loaded in the user log. That'll lead me back to here, which would be go to the player database. There it is. The player database is load player is similar. It's just overridden in overriding the entity database load. Sorry, this one is overriding the entity database load. So it goes to the input file stream players.txt, and from that file stream is just a list of players, list of player names, which then it can later load the information from a different file. So we get the name of the player, get rid of the white space after it, and then call the function load player name, which then brings us up to this one. The reason we're doing this is because we're storing each player's stats in a separate file called playername.plr. So my name would be Chris, my text file would be like chris.plr. So in here it's just a similar process to what we had in the item database. We've got the entity ID, the temporary variable to get rid of all the bracket ID bracket kind of things, in the text file. So player file name is pretty much just creating the proper file name, like I was saying, .plr. The input file stream creates the file stream to the file, and you have to pass in the character string. And then again, a similar process to the item database. We load in, this one is for bracket, ID bracket, and load in the ID. And this is passed into the map as the ID and the entity ID. So then again, another similar process to the item database. So we're loading in the actual player this time, and this operator is overridden in player. So if I can find that now, I'll show you. Okay, here's the overriding operator for player. It's in player.cpp, unlike item overriding operator, because that was in item.h. So it's just so you know where to find it if you need to change anything. So pretty much it's again a similar process, reading in the name, get rid of the ID, reading the password, and set it in the player.password. Reading temp, which would be for the rank, and we can use that to get rank and set the password, and it's pretty much just repeat. There are, however, a few differences, such as this line here. This reads in the attributes from the file. So you can see here that the last thing we read in was the hit points, but in the text file, hit points is here, and the next thing is next attack time strength and all that thing. So sorry, next attack time comes in here, but then the base attributes are written in for the player. So what happens is another overriding operator. So if I find attributes.h, it's down. Where'd it go? Ah, sorry, here. We can see that it's overriding again, right? Reading them in and writing in the separate places. So it's just a similar process, just repeated. Again, the inventory is slightly different. As you can see, it's inventory and a list of the item IDs. So then it's just another way for reading them in and setting the player's inventory. So that's pretty much it for loading them in. Maybe a little bit too much of an in-depth explanation, but it's handy to know. Okay, so the next things are we set up our listening manager and connection manager with our telnet protocol and our handler we want to call. I'm not going to go over these too much because the lads have gone over them in the screencast beforehand. So we pretty much just set the listening manager's connection manager here, and then we add the port 5100 to it. We get the timer of the game and reset it back to so it'll be started again, and we set the game running is equal to true, and then we go into a loop pretty much that runs for the entire time the server's up. It's pretty much the listening manager listens for any new connections coming in, adds them to the connection manager, and the connection manager checks if there's any data in them, any data being sent to the server, and if there is, it sends it to the handler. This is pretty much just to make this thread yield so that other threads can gain some processor time. And then we've just got some error handling down the bottom, just if there's a socket lib exception, thread lib exception, or a normal exception, standard exception, and otherwise one we don't know. And finally, just whenever the server shuts down, we've got down here that the player database will save all the things, and that's a similar process to loading as well, that the output file stream has been overridden for a lot of things so that it knows how to output them. So the next thing I'm going to go through is the logon handler, seeing as when someone logs on, it's going to get a connection and it's going to pass them into the logon handler with their input from the server. So find that here. Actually, it's in C++ file. Logon. So this is the handle function that's going to be called in our logon handler. It's pretty much, it'll have the data sent to the handler from the client. So the client sent to the server, gone to the connection manager, and coming here to the handler. And this is a check just to check there's too many incorrect responses, so it'll just close the connection and it won't worry about it anymore. If it's a new connection, meaning that the player hasn't entered anything into the first input yet, like their name, it comes in, and this is where we can check. I'll show you in a while when I run the program that when the player loads telnet and connects to the server, they get a prompt telling them to enter their name. and it can be either name or new to create a new user. So this is where it comes in. We come in, we turn their input string into a lowercase, and if it's new, we create a new user. So we set the state to creating a new user, and send a string back to the client, prompting them to enter their desired name. Next, it comes in, the server will run through it again. It'll come down, it won't go into new connection because the state is now set to new user, and this is where we're going to create our user. What hasfull does is it checks the player database to see if the name's already there, and if it is, it gives us our mhours++, which we have to check for up top to see if there's too many of them. It sends a protocol back saying the name's already been taken. Standard server stuff. It then checks if the name is in an acceptable format, so I'll actually just go and show you this. It checks if any of these characters are in the string. If they are, it returns false because the names can't contain these characters. If it checks if the name size is right, the name must start with an alphabetical character, and it can't be new because we're entering that to create new users. So I'll just go back up. Enterpass new user. Again, if it fails, it just increases the amount of errors and replies with a string. Otherwise, the name was acceptable, and we're now proceeding to the stage where we're getting them to enter a new password. We set their name, we set the temporary name variable to the input they've given us, and we send them back another string prompting them to now enter their password. And to send the string to the client, something I forgot to say beforehand, is we use the protocol, which the protocol of our connection, which in this case it's telnet. So we do basically our telnet.send string. We pass in the connection we wish to send the message to, and the message we want to send. Okay, seeing as we've just sent a message back to the user asking them for a password, the handler returns, and when the user sends us the next message, we've set the state to enterpass, so we go into the if condition with logon state is equal to enterpass. The first thing again is more error checking. We just make sure that there's no white space. Using the basic lib white space, the find first of basically looks for the first type of this character in the string, and if it isn't there, it returns in end position. So if there is one, we basically increment our errors again and send another message back. Otherwise, we send the user telling them they've basically been registered now, and we create a player object, set the player object's name and password equal to the temporary data we had, the temporary name and the input they've just sent us, which is the password. Then we continue on to add them to the database. So if the database size is equal to 0, they're going to be the administrator user. So we set the rank is equal to admin, and their ID is equal to 1. Otherwise, their ID is equal to the last player ID plus 1. Then we just go to the player database, add player, which will add them to our entity list and to I put them to a text file. So I'll just go into this to show you how it works. Okay, so first of all, it checks if the player ID and the player name are already in the database, and if they aren't, it then adds them to it. So using the player ID as the key, it passes in the player object. Next, we create an output stream to the file players.txt. So we're going to be adding the player's name to the file where we check which players to load, and this standard iOS app is so that we can append it to the end of the file. So then we use the file output the player name. Seeing as name is just a normal string, it doesn't do any form of special output, it just outputs to the name. However, next we go into save player with the player ID, so this does a special outputting for us. First we again check that the player is inside the database, otherwise it'll return from this again and not output them to the file. So if we find the player in the database, it'll return an iterator that points to it. We can then use this iterator to get the name. We call it iter to the second dot name because second is the data part which would be our entity in the map. So like the first part is the ID. So then we use this and turn it into the file name, which would be the folder / the player name.plr. And then we create an open file. We create an output stream to the file, and then we use that file to write to it. So for the very first one, it would be similar to what we did for reading in. We write out the ID and the player ID.